Okay, so we're going to look specifically at assignment 7A. I want to go over the 4 drawings that are in there. I'm going to pull each one of the drawings up in AutoCAD, and I'm going to point some things out for each. So as I go on assignment 7A, there are 4 drawing guides here, okay? You'll notice that there is 1, 2, 3, 4 PDFs, okay? If you click on those PDFs, you want to create your drawings to be exactly like what you see here, meaning you're going to draw the parts, okay? And then you also have the assembly on page 687 that has the details there, but these are the separate parts. And then you're going to notice that down here in the title block, it tells you this is an A-size border, and this is actually on a 2-to-1 scale. We still drew this 1-to-1. I'll show you that, but we brought the border in half scale, okay? Because the 2 is ahead of it. I'll show you that in just a bit. So let me pull up the set screw in AutoCAD so you can see what that looks like. Oh yeah, this is machinist vise. And I need the set screw. There it is. All right. So here is, if you get that, that's because of the border. There's something in the border that's unresolved. Always just say ignore, and it's totally fine if you pull it up a drawing with a border on it. So first of all, you are going to draw the set screw 1-to-1. The information for the set screw is on page 687 of your tech drafting book. So if I go underneath here, it is going to be part of the machine vise, and it is located, oh, it's right here, right in the middle. Okay, it's number 10. So this kind of gives you the details of it, and then you're going to be creating the 2-view drawing that you see here, okay? Now, you're drawing this 1-to-1. So as I said earlier, you'll notice our scale is 2-to-1 for our border. So how I pull this in, I want to show you. I'm going to do an insert from block libraries. My border is here already, so I'm just going to grab it, but you would navigate to your border otherwise. And then what I'm going to do is, let's kind of scooch this over. I'm going to left click it and I'm going to pull it in, redefine the block. Now, right now, this border on my cursor is 1-to-1 scale. And you can see if I put that around my set screw is so much smaller that the dimensions are going to be really big compared to the part, okay? So this is where, instead of pulling this in 1.5 or 2, we're going to pull it in at 0.5 because the part now is going to be, we want the part to be bigger. So my scale, then I'm going to left click where I want my base point to be. And then I'm going to put in a scale of 0.5, not 1 or 1.5 or 2. Okay. And then enter. And then now I'm going to fill in my information. I'm just going to hit these like this. And then I'm going to do okay. And now the border is the size that's appropriate for the dimensions. Okay. So the 2-to-1 means that I'm pulling in my border half scale so that technically things are on my drawing are 2 times what the scale is on the border, but it's drawn to 1-to-1. Does that make sense to everybody? Okay. So the scale in the title block is only to do with the border and how we bring that in. Okay, so once that's in, you're going to notice that this front side, this is threaded. This is a number 12 by 24, number 12-24. So it's a number 12 screw, 24 threads per inch. It's considered a UNC, okay? And then 2A just means that it's an external thread. You don't have to have the 2A on there, but it's there. Then you're going to notice that we have this kind of hatching part here. All this was I didn't want to put, and it's just an example of, you don't have to always put a full section, but the rule of dimensioning is here. If I didn't put that in here, this edge where the depth of the cut is, I wouldn't be able to dimension to it because it would be a hidden feature. Okay. So I put that little like breakout section, we called it. And all I did, this is just lines. This is just lines that are kind of jagged looking. And then there's hatch in the inside here. That's it. That's it. Okay. So it's just to show where that is. And then you'll notice that where we have this external thread, the outside diameter represents the major diameter. The inside diameter represents the minor diameter. Okay. And there's 2 ways that you can do this. All right. Most often, the minor diameter is a 32nd smaller than the major diameter. That's a very common number. Okay. So If you don't have, for instance, a drill chart next to you, okay, or you don't want to necessarily look it up, what you can do is just offset so that the inside diameter is a 32nd smaller. So a 32nd is 0.03. A 64th is half of that, right? So you would offset this line on the outside 0.015 down and change it to a hidden line. That's what that is. So if I dimension that, for instance, and if I go in here and I dimension from here to here, well, of course it's 0.025. It's about a 32nd of an inch, I guess, but so that you can see that. Oh, I know why I did it like that. This is a very small screw. It was almost too small to see. That's why I did that a little bit bigger. So you just want that gap so that you can see that hidden line so that you have simplified representation of the thread. Yeah. So if I would have done, for instance, if I would have done an offset, and I think I remember doing this. If I would do 0.015, it's really tiny. And when I would blow out or when I would zoom out, you almost couldn't even see it. Okay. So I offsetted it just a little bit more because of the size of the feature. Most often it's about a 32nd of an inch when it's larger diameter threads. Okay. All right, so I wanted to point those couple things out. Any questions on that one? Okay, the parts are actually pretty simple. I think I think I told you there's like a challenge part in each one of the assignments, but the other ones are pretty straightforward. So that's the set screw. Let's look at the next one. I'm going to open up the handle rod. Okay, this is the handle rod. And you're going to notice we did a breakout section again on the right-hand side. The reason we did this, okay, I would have had to create another view with the circle views. And honestly, it's a very simple part. Sometimes it's like, do we have to, put all, I'm not going to say effort in, but we can get the same idea across here. So you're going to notice that we see a through hole over here. If I didn't have the breakout section, I would have hidden lines. I would not be able to dimension the size of that in this view, and I wouldn't be able to dimension to the location because it would be a center line to a hidden feature. Okay, so by doing the breakout section, just like we did on the previous one, then now I can dimension to it. Okay, so that's a very big rule. The other things on here I think are pretty straightforward. So this is a 1-to-1 A-size border coming in. All right. The next one that we have is going to be the jaw plate. All right, so the jaw plate here, this is again a pretty simple part. From the front, you're going to see one circle inside of the other, but on the right side view and through this note, you're going to notice that we have a through hole of, I think it's 9/32, 0.281. And that's going to represent the smaller hole on the inside, okay? And then we have this V. That means that this is a countersink. So this is kind of that V-looking type of a hole, if you would, that's going to bury the head of a flat screw, okay? And so that V is going to be at 82 degrees. That's an included angle. So when I look at the angle that's created here, okay, that's 82 degrees, if you would, between those two surfaces. So when I construct this, I construct one side at a time. So from horizontal, if I dimension this from that horizontal line, half of that is 41. Does that make sense? So I just wanted to just show you a little way to do that. I'm simply going to copy this over. I'm just going to put it over here and I'm going to get rid of that stuff. So let's say I have the outside of my part and I want to put the hidden lines in here. How I would construct this. Now, I'm going to construct it with object layer first, okay? So I'm simply going to put a line in the middle. So I'm going to find the midpoint and the midpoint, okay? So that's in the middle. That's representing, oh wait, that's not in the middle. That's okay. I'll put it where it's supposed to go. So it's offset an inch from the bottom. inch. Okay, so this represents the center of my hole. Okay, now what I'm going to do is I'm going to offset so that I achieve that diameter of 0.281 on either side. So half of that would be 0.1405, right? So I'm going to do another offset, 0.1405, enter, and I'm going to go up and I'm going to go down. Okay, so that's going to be this part of the hole, the bottom part. Now I need to show the outside diameter. The outside diameter, the 0.531. If I dimension this to this, this is my 0.531, the outside of that. So what I'm going to do now is I'm going to offset from the center so that I get half of 0.531, which would be oh, that isn't right. So what would that number be? 0.2655. Can't do them in my head. Okay, so offset 2655. Okay, so I'm going to go from the center up and from the center down. Okay, now this is that outside one. I need to rotate that so that it's going to be at that 41 degrees from horizontal. Okay, so I am going to use my rotate command, click on it, enter, click this as my base point, and now this is where I rotate. I'm going to go a negative 41 degrees, and now this is at that angle. Okay, now what I need to do is I need to trim these things off. Now this isn't quite making it to that 0.281 or 2.281 diameter. So I need to go underneath trim and I need to extend this out a little bit, otherwise it won't trim. And then I can go back up to trim and I can say trim that one off. Okay. Then I'm going to do the same thing on the other side, and I am going to rotate, and this one is going to go from that intersection 41 degrees because it's going in a counterclockwise direction this time. Extend that again. Now you could do a mirror on that. I just wanted to show you maybe twice so that you can see how to do this. There we go. Okay. So then now as we look at this part, this would be hidden lines. And I'm just going to simply select those lines and change it to the hidden line layer. Okay. Then I'm going to hidden line layer and I'm going to add the line between the two. Now you're going to notice that I don't have dotted lines, right? So that means I'm going to have to select each one of those lines and I'm going to right click and go to properties, and the line type scale for that, I'm going to start with 0.5. Looks like it did it, I think. So I'm going to X out here and I'm going to hit escape. And now I've got dashed lines. So make sure that you always change that line type scale. So when it's printed out, or when we see it as a PDF, I can see that those are hidden lines and they're not, even if it's on the right layer, you've got to change the scale. And then lastly, I'm just going to take this line, I'm going to extend it out a little bit. Remember, center lines have to extend beyond the part. Okay. All the other lines stay within the part. And then we need to put this on the center layer and then change its scale, LT scale, properties, line type scale here, 0.5, didn't go, 0.25, didn't go, I don't think. Yeah, it's a pretty short line. Now it went 0.125. So you got to play with that so that you can see that it's a center line and not a continuous line. Okay. So I wanted to show you how to create that. Otherwise, everything else on here, this is one-to-one. You know how to put those notes in. I think we've had some practice on that, but yeah, that's that. So that is the jaw plate. And then the last one in this assignment is going to be the sliding jaw. This is your challenge part. Okay, this is your challenge part. Now, as we look here, there's a couple of items here. Now, between the actual drawing from the book, page 687, okay, where our machine vice is, down here in the lower right-hand corner is where we see the sliding jaw. The view we see right here is looking at the back side of that, okay? So these are two holes or two threaded holes where we would attach the jaw plate to, okay? So those are going to be looking in this direction. So if I go back to my sliding jaw here, and I look at the projection, here is that face. And then if we look to the left, this is going to be that view. Those are going to be those two threaded holes. Okay. So let's look at why I did what I did here. So if I would just have standard views, so my right side view, front view in the middle, top view. Okay. What ends up happening is a couple things. Number one, these two countersunk threaded holes from the bottom, I never get to see as features that are visible. So first of all, you can see here that I did a breakout section, and this is to get the location in this direction of how far back from the front of that sliding jaw we are. Remember, I cannot dimension to hidden center lines. Okay, so that's why I have to have a breakout section on this. Then we did a section through there. So here are my section lines. Okay, my view is in back of the section lines. Remember, if my section lines are pointing to the right, my view is on the left. If I'm pointing to the right, my view is on the, I'm sorry, if I'm pointing to the left, then my view is on the right. They're always opposite. So it has to be in back of the arrowheads, we say. So here then is looking in this direction, and it's going through because I need to see these counterboard threaded holes as actual visible lines so that I can not only dimension their location from side to side here, but also what is the size? Okay, what is the size? Now, as we look at this call out, this is a couple lines here. Now we're actually starting at the bottom and going up. So we have a counterbore diameter of 0.218. That is this size right here. Okay. So if I take a dimension and I put it in here, okay. Why is that? Oh, I don't think I got to the edge, but it's 0.21. It's 0.218. I didn't get to the very edge. So that's how wide that is there. Then if I go up the next line, this section right here is that number 12-24. So you need to find out what is the major diameter on a number 12 thread. That's going to be the outside. And then the inside is going to be then the offset for the minor diameter. Okay. Can be about a 32nd. So on the diameter. So it can be 0.015 can be the offset in. Okay. That goes up to what this cutout is. I'm going to tell you, there is one exception I am making to drawing on the part or dimensioning on the part. And as I told you, we always try. If there's a way that we cannot dimension on the part, we always pull things off, always. But in this case, I had no other good place to go with it. You'll notice that where this is located, this is the depth of this cutout. And the depth of that cutout goes right over the top of the holes that we have here, which then are dimensioned location-wise down here. So I felt like, I think I'm going to leave that there. I felt that that was the best place. So if I pulled it down here, it just gets too cluttered. And then you can see that it's kind of so close to the center line. So this is the one place you might be like, wait a second, Kelly, you've been giving me points off because you tell me I can't dimension on the part. Try always not to, because usually there's a place we can go. But this, again, there's a lot going on in that view. So sometimes you have to improvise. Notice there are no other places. So I needed to point that out. So if somebody did notice that. I think everything else is pretty self-explanatory. I think going from the drawing here and just creating this, I think would be hard, but at least you have the orthographic projection and all the dimensions on here that you can duplicate then, okay? So you need to create a front, top, right side view and a section going through as well, okay? questions as you glance at this at the moment? Ava?
You on the left, do not have to show the minor diameter on the,
Are in there. But because it's a section, we see both.
oh.
Yeah, so so the question in the room was, Ava was asking, don't you have to show the threads on this one up here? Because this is a section going through here, we would see both the major and the minor diameter. So they become visible lines in a section view when we look at it as the circles. Does that make sense? Yeah. Yeah, we wouldn't see the hidden on the outside. But when we are looking this way, for instance, now we have to show both lines, yeah, for the depth. Oh, and this was another one I wanted to show you really quickly. This was a dimension I added. This is not a dimension that you're going to see on your drawing. As we look at, where's the note for this? Oh, right here. So you're going to notice that this is a 1/4 20, so a 1/4 20 threads per inch UNC. The depth here is 0.625. That is always referring to the depth of the thread, the depth of the thread. So when I look at creating this depth from that face to the end of the thread is 0.625. Oopsie, 0.625. It doesn't give you an extra extension for the drill. You always have to drill further. Do you remember what that number was? It's always at least half the diameter of the thread. So if I have a 1/4 inch, 1/4 20 socket head cap, or it's 1/4 20 thread, that means at least you're going 1/8 of an inch beyond, half of the diameter, okay? I think mine looks like it's about 1/4 of an inch or a little bit more, but if you go a little bit more, but it has to be at least half of the diameter, okay? So, so that depth becomes kind of arbitrary. You are the designer, but don't push it through, okay? Don't push it all the way through. We want it to be just a little bit beyond, and it has to be at least half the diameter. Why do you think it needs to be at least half the diameter? When we tap this, there's going to be some spiraling of chips, and we don't want to bottom that tap out, and then all of a sudden the chips start to accumulate, and taps don't like that. Or you won't really tap to the bottom, the full depth. That would be a problem. Okay. So I'll get rid of that dimension. I added that earlier when I was going through the drawings. Okay, so that was really what I wanted to kind of show you in terms of just giving you some details on each one of these drawings as you're approaching them. So if there aren't any questions, oops, I do have a question. I'm so sorry. Oh, Dominic, on the handle rod. Oh, good question. Good question. Where should I look to find dimensions? I don't know, Dominic. We had a really good assignment on threads. I think it was just last week. You might want to look at the resources there for what the size is for a number 12-24 UNCR. Okay, so look there first. And then I'm going to go back to the handle rod for your question. So your question was, why did I draw to that? I will tell you exactly why. Open. Oh, I think I have it open. Yeah, so for this one, let me look. So the handle rod, and then I've got to look at, yeah, okay. So if we look there, the reason that this is 0.3125, because the book has something else a little bit different. The book has, I'm going to go underneath here. So the handle rod, where is that? Okay. So the handle rod is right here. And you're going to notice that they're calling out 0.312 to 0.311, okay? 0.3125 is 5/16 of an inch. That is going to be stock size that we can get a rod in, okay? Now this rod is going to fit through the hole that we see here. And that hole is 0.4375, which is going to be, I don't remember the fractional inch, but this is a standard drill size as well. This handle is going to freely move up and down within that hole, Okay, so what we're doing is rather than turning this down to 1,000th of an inch tolerance, we're saying we're going to take whatever we're getting from our from the material supplier, and we're just going to keep it at a nominal size 0.3125, which is 5/16. And then this is going to fit into freely and be able to move freely up and down within that diameter of 0.3438. Okay, does that make sense to everybody? Okay, so that's why using stock sizes instead of something special to save money, like quite honestly. Okay, and not have to make something so critical that isn't critical. It's just a rod fitting through a hole. That's it, to freely move. Does that help, Dominic? I'm sorry I didn't see that right away. Okay. All right. So if there's any other questions on this assignment or those parts? All right.
I do have a
Yeah.
question on the slide jaw.
Yes.
So for those screws that that is the 1224, did you by on your drawing, did you by any chance make it smaller so that you could tell that there's a difference in the diameter? Because I think I have the right diameter, but it looks pretty close to the 0.218. So like it doesn't look like it's there's a difference there.
I may have, hold on, let's just see what the diameter is. So I've got 0.21, 0.216, which is I think this is the counter bore. And then the outside diameter, it is very close, quite honestly. All it is it's just a recess. So 0.18. I don't remember what a number 12 is off the top of my head.
Okay.
So it is close though, Tasia.
Okay.
Yeah.
All right.
Any other questions? Why are your example drawings black and white? Do we need to make ours like that? The reason mine are black and white is because it's are you talking about on the exam, like on the drawing guides, or do you mean when I print them out? The drawing guides, yes. I find, especially when I'm using yellow and that cyan and the pink colors, and I make a PDF that's in color, I think it's harder to read and see. I think the PDFs just are easier to see in black and white. And typically, also when you print out the drawings for somebody to use in industry, they're gonna be in black and white. So I think they're just a little bit easier to see that way. Yeah. Okay. Any other questions? Okay. If not, then you're going to be ready to get started on that. And I hope I gave some insights on, how to approach those.